Hello everyone, once again welcome. In the last session we talked about how to visualize the data that we have collected. In the last session we talked about one of the very common, famous and effective method of data visualization method called as histogram that helped us to understand how the data is spread and what is the central tendency of the process, what is the range of it. And I talked that there are multiple types of distributions available, and we have been going through a very bell curve kind of distribution, which is a very common distribution called as normal distribution. It's always advisable to start your data analysis by making a distribution first, finding the type of distribution that can tell you a lot about the distribution itself. In this session we are going to talk about another very famous, effective and widely used data visualization method called as scatter plot. As you can see on my screen here, scatter plot basically tells you the relationship between two variables x and y. Now x is the independent variable that can behave anyway, y is the dependent variable which is the output. If I talk about a y equal to fx, x is the input, y is the output. To give you an example of scatter plot, a very common and a very basic example of a scatter plot, fuel prices, if you have to plot the fuel prices over last 10 years for example, so you write about 2011 till 2021, what was the fuel price on 1st of January each of these 10 years. So in the x-axis, the below, you write 2011 1st January, 2012 1st January, 2013 1st January and so on, and you write the fuel prices. The best guess is it has gone up. You see now it has gone beyond 100, 105, 106 these days. So the fuel prices, you will be seeing it is going up. So you see a relationship between x, which is the year here, and then we have the y resultant, which is the fuel prices here. So fuel prices is a result of one of the factor. Here we are taking one of the factor is the year, and I see a relationship where I see a line going up. So I see a very positive relationship. Now why it is a positive relationship? Because as and when the time is moving up, fuel price, which is x, is also going up. So I call it positive, strong relationship. And I see a definite correlation between the fuel prices and the year. Every year fuel prices have gone up. So can I say that there is a relationship between x and y? There is a correlation between x and y? Answer is yes. There is definitely a correlation between x and y. But does this also mean that this trend will continue, that in the coming year the fuel prices will be even higher? Can I say, looking at this graph or looking at this picture, the answer may be yes. Some of us maybe would like to believe it because that's how the trend has been. So it gives you a trend. But that is where the caution comes up, which is it's a very famous statistical quote, that is, a correlation is not causation. That means what happens in the future cannot be determined by looking at the trend. So to give you another example, I call it the silly example, wherein every time I am watching cricket and Sachin Tendulkar, one of the famous cricket players, whenever he is playing above 90, when his score is above 90, he is about to score a century. Whenever I have seen him above 90, he is playing, and I start watching cricket, that means, and every time I am watching it, he'll be out. Would that mean that me watching cricket is making him go out? But if you look at the trend, it will be 100%. There is 100% correlation between me watching cricket match and he getting bowled out. So that means I am one of the factors for him to get bowled out. Now, however, I see a strong correlation, I see a strong trend, but as I said, the famous statistical saying, correlation is not causation. You might find a strong correlation between two things, but one is causing another. That cannot be determined, cannot be guaranteed. So that is what we have to understand when I talk about the scatter plot. The scatter plot tells us the relationship between two variables. One is x, one is y. So let's look at this picture here on my screen that you can see. we have lot of type of scatter plots that I have built here. So the first type that you see, it's a perfect positive correlation, where whenever x is going up, in the same proportion y is also going up. The second chart says high positive correlation. That means there is very high positive correlation is there. That means whenever x is going up, y is going in a higher proportion going up. So it's like you increase x by one value and y increases by more than 2 or 3 value. That's a very high positive correlation. A perfect correlation is that it is not going in multiples of proportion. You increase x by 1, y also increase by 1. So it's a perfect correlation, positive correlation. The third picture that you see on that screen is talks about the low positive correlation. Low positive is whenever x increase 1, whenever you increase the value of x by 1, the value of y does not increase by 1, it increases by 0.5 or 0.4. So there is a positive correlation, but not very positive, low positive correlation. The another picture that you see, the picture number 4, it says low negative correlation. What is a low negative correlation? But before that, let's talk about perfect negative correlation. Picture number 6 here. The way we had perfect positive correlation, wherein when you increase the value of x by 1, y value also increase by 1. So perfect negative correlation is whenever you increase the value of x by 1, the value of y decreases by 1. So it's other way around. So that's called perfect negative correlation. Similarly, you have high negative correlation. Whenever you increase the value of x by 1, the value of y decreases by 3 or 4 points. Similarly, you have low negative correlation, which is whenever you increase the value of x by 1, the value of y decreases by 0.3 or 0.4. But there is a negative correlation, but not very high, it is there. At the end, if you look at the picture number 7, it talks about no correlation at all. Whenever you increase the value of x, sometime y value increases, sometime decreases, sometime increases very high, sometime decreases very high, sometime decreases very less, sometime decreases very high, sometime there is, or there is no impact also, and there is no trend also. There is no proportion, there is no specific trend. So which means there is no correlation that we can see between x and a y in these situations. So even if there is no correlation in the picture, as I said, correlation is not causation. Similarly, no correlation does not mean no causation. However, the picture says there is no correlation, but as I said, you cannot predict simply by looking at the picture. There may be a causation, but from the picture it is not evident. Similarly, so when you look at a picture, so scatter plot is a very good way of understanding a relationship between x and a y, but basis that relationship, nothing can be predicted what's going to happen in the future. The future process performance cannot be simply predicted just by looking at the picture itself. There may be many factors that may be impacting that process performance that you see. So if I go back to my fuel example, where the value of fuel is going up in the future, there may be various factors. Let's say if there is a war, or because of corona or pandemic that came up, or if there is any global recession that comes up, there may be various factors that might impact the overall value of the fuel. Number of years, they are only giving you a trend that value of fuel is going up, but there may be many factors that may be impacting the overall value of the fuel here. So that's we need to understand. Correlation is not causation, and here we have scatter plot telling us the relationship between two variable x and a y. In the next session, we'll look at other type of visualization method. Till then, keep watching. This is Shivendra Sharma here. Thank you.